Okay, our last video on circle properties is looking at cyclic quadrilaterals. So if we have a circle and we place a quadrilateral inside that circle, we get some unique properties that we can use to our advantage. First of all, let's define all of these terms that we're using. So a cyclic quadrilateral is a quadrilateral whose vertices all lie on a circle. The angle CDE that we have over here in this diagram, so this angle just here, is an exterior angle to a cyclic quadrilateral. Okay, exterior meaning outside, angle meaning angle. Angle ABC is the interior opposite angle. Okay, interior because it's inside the circle, and opposite because it's in the opposite segment from the chord CD. So this is our exterior angle, that is our interior opposite. So, some useful theorems. Theorem 14, the opposite angles of a cyclic quadrilateral are supplementary. So what we're saying here is that the angle here plus the angle here is equal to 180 degrees, and the angle here plus the angle here are also equal to 180 degrees. So all we're saying there is we know that all of the angles in a quadrilateral have to add up to 360. If we then place that quadrilateral into a circle, we get some funky things happening. Now the opposite angles are exactly half of the total of the angles in the quadrilateral. Our symbol for that is just a quadrilateral in a circle. Theorem 15. The exterior angle of a cyclic quadrilateral is congruent to the interior opposite angle. So if we have our quadrilateral with a line coming out, we have that this angle up here is equal to this angle down here. So let's put this into practice. Determine the values of A and B in the diagram. So we're looking for the angle EAB and the angle ABD. So first of all, we need to notice that our quadrilateral ABCE is a cyclic quadrilateral. So ABCE is a cyclic quadrilateral. So what does that mean? Well, it means that angle EAB plus angle ECB is going to be equal to 180 degrees. So we have, based off the fact that it is a cyclic quadrilateral. So we know that angle ECB is 72 degrees, so angle EAB is going to be equal to 180 minus 72, which is just equal to 108 degrees. Okay, so we're also given that these two lines here, E to A and D to B, are both parallel to each other. So we can't forget our parallel rules. So we have co-interior angles here, sometimes referred to as the U rule or the C rule. We know that the angle EAB plus the angle ABD is also going to equal to 180 degrees. So we therefore know that angle ABD is going to equal 72 degrees. And last example, not only for the video, but for our booklet here, prove theorem 14, which is to say the opposite angles of a cyclic quadrilateral are supplementary. So there's our circle. Let's draw any random quadrilateral inside it. Okay, what we're wanting to prove is that A plus B is equal to 180 degrees. So how are we going to do that? Well, we're going to use some of our angle properties in a circle. So somewhere in this circle, we're going to have our center O. And we can draw two lines from other 2 points on our quadrilateral. So let's label our quadrilateral Q, R, S, and P. So PQRS, sorry, I should have said. So what we can see here is we've got 2 different angles of ROP. We have the reflex angle and the non-reflex angle. So I'm going to label my reflex angle in orange. That's going to be this angle up here. And I'm going to label my non-reflex angle in purple. So that's this angle down here. Now, both of these are subtended by different arcs of R to P. So we've got the arc RSP and we've got the arc RQP. Because they're also going up to these 2 other points, we can use the fact that they're subtended by the same arc. So we get the following properties. Angle ROP is subtended by RSP, so that's our arc. So we get that the angle ROP is equal to 2 times A. So this is our non-reflex. So our purple angle here is equal to 2A. If we then flip this entire thing on its head, well, first of all, let's not forget our symbol. Okay, so there's our symbol in there. The reflex is also true. So the reflex angle ROP is subtended by RQP. So let's call it R for reflex angle ROP is therefore equal to 2 times the angle RSP, which is B. So that is, again, using the same property over there. So what we get here is the reflex, which is equal to 2B, and the non-reflex, which is equal to 2A, have to add up to 360 degrees, because the reflex and the non-reflex counterpart are going to add up to the total of the revolution. So 360 is equal to 2A plus 2B. We can take out a factor of 2, divide through by it, we get 180 degrees is equal to A plus B. So there we have it. Opposite angles of a cyclic quadrilateral are indeed supplementary. They both add up to 180 degrees. Thank you very much for watching.